Hello, 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 hello. Hello guys, in this video I'm gonna again repeat the same example that we solved it in the last two videos using two different ways. We solved it first using the nodal analysis, which is basically the most convenient and the easiest one or the easiest method to use it in that particular example, but not always the case. Then in the last video we use Thevenin equivalent, and this time we're gonna use superposition theorem. Okay. So just a recap or a review on the superposition theorem, it says that the voltage or the current in any on any element in the circuit is just a component that comes from each source in this circuit. Like for example, if we have like a circuit like that, okay, it has V1, it has V2, two batteries, it has like a current source I, and it has a resistor. Okay, so the voltage across the resistor and the current across that resistor, let's call it V and I. Okay, so the V is basically V1 plus, not V1, let's call this E1. Not to confuse ourselves. So E1, E2, and IS, for example, whatever. So V is equal to V1, V2 plus V3. What is V1? So V1 is the contribution of E1 into the voltage V. V2 is the contribution that comes from the source E2 into V. V3 is the contribution that comes from the current source into V. I is the same, three components, I1, I2, I3. I1 contribution of E1, I2 is the contribution of E2, I3 is the contribution of IS, the source is the current source. Okay. So the superposition tells you that if you cancel all the sources and keep one source, you're gonna get the component or the effect of that source on that element in current and the voltage. Okay. Then you repeat the same with all other sources. Add them together, you get the full voltage and the full current of that component, that you wish to solve for. Okay. In our case here, we want to solve for A. That's basically the question. So you have here two sources, IS equal to 5 angle 30. It has a phase 30 degrees, and the voltage source with a constant value called 10. Okay, there is no angle, there is no phase. The phase is zero. Okay, if the phase is zero, we don't write it. So we have two sources. So we're gonna solve the circuit two times. One when we cancel the current source, and the other one when we cancel the voltage source. Okay, we get two contributions to IA dash and IA double dash, or IA1 and IA2, and IA will be IA1, A1 plus IA2, or IA double dash plus IA double dash. Okay, that's what we're gonna do. Okay, so let's first cancel. Let's first determine the contribution. So in here, IA has two components, IA dash plus IA double dash. IA dash come from, let's call it the voltage source, VS. And IA double dash come from the IS. So we're gonna solve this circuit twice. The first, when we cancel IS, so we get the current IA dash. Then we cancel VS and keep IS, we get IA double dash. Add them together, you get IA. Okay? Okay, number one. Let's cancel or let's make it like find IA dash, which comes from VS. Okay, we're gonna keep VS, but we're gonna cancel any other source, any other independent source. Again, this is very important. You might have a dependent source. That's not our topic now. An independent source is a source with a constant value. It doesn't depend on any other current or voltage in the circuit. So for example, here, this is equal to 10 volt. Whatever happens in the circuit, you know, it is always 10 volt. IS is 5 angle 30, constant value. Whatever happens in the circuit, it's always 5 angle 30. So we're going to cancel IS. Now, how to cancel a current source? You cancel a current source by canceling its effect. Cancel its effect. What is the effect of the current source? It makes the current, its branch constant, equal to the current source current. Okay, so the current in that branch is IS. So to cancel IS, basically make it zero, we know that we should make an open circuit, right? That's what we're gonna do. We're gonna do an open circuit here. We're gonna break the circuit. Okay, so the current will be zero. So this will be the circuit after canceling IS. I'm gonna make an open. This is IS here. 6 ohm. The capacitor G4, 3 ohm, and this. Okay. And if you have a branch with an open circuit and just one element, just remove this element so you can remove it completely. Okay. And the current here now is not IA, it's IA dash. The contribution of VS to IA. Okay, so we're gonna solve this circuit now. Okay, and the best way to solve it is basically using, we can use like maybe the node analysis. Okay, so on the node analysis, we look at the nodes with 3 branches or more. Okay, we have 2 nodes here. This node here, the first one has 3 branches, and this node as well has also 3 branches. We make one of them ground. You can choose the top one or the bottom one. Usually we do the bottom for some reason. Right? Maybe because the ground is like under us any time. So we're gonna ground the second one. And let's call this VA, for example. Okay. Now we apply the node analysis. Okay. So basically we apply the Kirchhoff current law at the node that is remaining, which is VA. So KCL, Kirchhoff current law at the node VA. You can call it by the way anyway. You can call it VP, V only V, whatever. It's okay. Okay. So we should assume the currents. So we have a current like that, a current like that, and a current like that. Let's call it I1, for example. This is I2. So Kirchhoff current law says the summation of the currents going into the nodes equal to the summation of currents that going out of the nodes. The node, I'm sorry. Okay. So what are the currents that is going into the node? 0. All of them are going out. Good. Now, what are the currents that are going out of the node? We have 3 of them. We have I1, we have IA dash, and we have I2. Okay, let's have I1 first. I1 is flowing into the 6 ohm resistor. So it's equal to the voltage across the 6 ohm resistor divided by the resistor value. Okay. So what is the voltage of the 6 ohm resistor? It's the voltage difference between its terminals. So it has 2 terminals, this terminal and this terminal. Why is the top one is positive? Because we assume the current going from top to bottom. So the top is positive. The bottom, which is the current is going to, is negative. Okay. So the voltage across the resistor is actually, this terminal has a voltage called the VA. We call it VA. It's unknown till this moment. The negative terminal is 0 voltage. That's good. That's known, and divided by 6. Good. Plus IA dash. We don't know IA dash as well. We wanted to find it. So IA dash is flowing into the reactance 3 plus G4. So we can draw this in this way. Just one reactance 3 plus G4 impedance, whatever you call it. 3 plus G4. This is 6. This is IA dash. Okay, if you draw it, it's legitimate to do that. Okay, so this will be VA again. So it flows in that way here. That's the positive, that's the negative. The positive terminal is VA. The negative terminal is the ground, 0 over 3 plus G4. We are not done yet. I2 plus I2. I2 is flowing in that way here through the impedance or the reactance minus G4. That's the positive, that's the negative. Goes that way, from the positive to the negative. So we know the positive terminal is VA, but we don't know the negative terminal voltage. But we know this is VS, right? Again, what is VS? So let's call this V, for example. So VA minus V over the reactance minus G4. Okay, what is V now? So we know that if you have a voltage source called VS or called E, whatever, and it has two terminals. The voltage source, what it does, it increases the voltage of the positive terminal, then the negative terminal by the amount of the battery or the source. So if this is V, let's call it V1 and this is V2. Example. So V1 minus V2 in that case equal to V. Okay, in our case, V1 is V. In our case, V2 is actually this one, it's a negative, which is 0, the ground. And in our case, Vs, by the way, is 10. Can go up here, so Vs is 10. Okay, so V is equal to 10. That guy is equal to 10 volts. So 0 equal to VA over 6, because we can neglect the 0, plus VA divided by 3 plus G4 plus VA divided by minus G4 minus or plus minus 10 over minus G4. Okay, so we can take the VA as a common factor. So this is VA 1 over 6, 1 over 3 plus G4 plus 1 over minus G4. And this will minus will go as a minus plus 10 over G4. So we can bring the 10 plus over G4 to the left-hand side. So minus 10 over G4 equal to VA 1 over 6, 1 over 3 plus G4 plus 1 over minus G4. So VA equal to minus 10 over G4 over 1 over 6, 1 plus 3, sorry, 1 over 3 plus G4 plus 1 over minus G4. And we don't need to do any simplification. We're going to use our online calculator, online complex number calculator to do everything for us. So, as we learned in the last videos, please watch them if you didn't, if you haven't. Okay, so that's the complex number calculator that we're going to use. Okay, and let's do that. So, we have here a fraction, so put two parentheses initially. The best thing to deal with this website is to use parentheses all the time. So we have in the numerator minus 10 over G4 minus 10 divided by, I like to do parentheses as well for the complex number itself, 4i. Again, we call conventionally the square root of minus 1 is called the I, not J, but we use J in our course in our electric circuits because we reserve or we book a simple I for the current. Okay. Okay, now the denominator, we have three terms. So let's make this a binder. And we have 1, 2, 3. Good. And we have a plus between each one. But yeah, first term is 1 over 6. That's easy. Second term is 1 divided by 3 plus G4, 1 divided by a parenthesis 3 plus 4i. Usually, you should or you must, let's say you must, because it might, here on that website, always put the constant before the J or the I here, okay? Because it might translate it differently or incorrectly if you do it I4. For I on that website is different from I4, okay? Always put the 4 before the I, okay? Finally, 1 divided by parentheses minus 4i. Let's review. So the numerator minus 10 over 4i, that's good. Numerator 1 over 6, 1 over 3 plus 4i, that's good. Plus 1 over minus 4i, that's very, very, very good. Okay, let's remove the spaces that we did just make it clear for us. And press calculate. It gives us VA equal to 2 point, you can 49, that's fine, plus 7.94, I'm rounding, J. That's Mr. VA, okay? But remember, we don't want VA, we don't IA dash. So if we go back here to the circuit after removing IS, this is IA dash. What is IA dash? IA dash is flowing through the 3 plus G4 reactance or impedance, okay? So it's equal to the voltage across that impedance divided by the impedance value. What is the voltage across that impedance? It is the positive minus the negative, which is VA minus 0, because the negative V terminal is 0, grounded, and the positive terminal here is all that node, which is VA. So IA dash, which is the contribution of Vs into the current IA, equal to VA over 3 plus G4. Don't do anything. So here in the same website, you take this, copy, the parentheses, put it, then divided by 3 plus 4i. Again, we use 4i is different in this website. 4i is different from I4. It will be translated differently if you write it I4. So please write it 4i. Please calculate. Good. So IA dash is 1.557 plus 0.55 J. Okay. Let's review if yes, that's the same answer that I get. I have to have the same answer, very, very close to it. Okay. Okay, guys. So what we did right now until this moment is to find the contribution due to IS. Now we should find the contribution due to IS. Number two. Find IA double dash, which is due to IS. So we're gonna keep IS now and cancel Mr. VS. How to cancel VS? Cancel its effect. What is the effect of a voltage source? Let's see what does the voltage source do. The voltage source E, for example, it makes the voltage of the positive terminal greater than the voltage of the negative terminal by the amount of the battery, E. So in that case here, for example, V1, which is the voltage of the positive terminal, minus V2, which is the voltage of the negative terminal, equal to E. We know for a fact that if you have a short circuit between two nodes or terminals, they have the same voltage. It means V1 minus V2 equal to 0. So to cancel E, we should make a short circuit like that. And in that case, you can just remove E. Okay, so let's draw the circuit and then cancel the voltage source. So we have here for J, we have the 3 ohm resistor. We have IS. We have the 6 ohms. We have, we have a reactance afterwards. Minus G4. Then we have our voltage source. We're gonna cancel it right now. Don't worry. Okay, that's Vs. So we want to make this node equal in voltage to that node. We cancel its effect. So how to do that? Make a short circuit like that. Then remove it completely. So we're gonna remove it. And it looks ugly, right? So we can also remove the short and make it straight. Like that. We canceled the voltage source. Congratulations. Okay, good. This is now IA double dash. Gonna find right now. Okay. So again, if we look here, the best way to solve it is using like the nodal voltage method. Okay. So we search for the nodes with more with 3 branches or more. Okay. So we have 2 of them. This one here, that's a node. There's 4 branches actually. 1, 2, 3, and another node which is that one here. 2 nodes, 3 branches or more. We ground one of them as you like. If you want to ground the first, the top one, it's up to you, and leave the bottom one, or vice versa, whatever you like. I'm gonna do the conventional way, which is grounding the bottom one. You can do the opposite and check the solution. You must get the same solution. Okay. Okay. So we grounded. Let's call this V or VA, whatever you like. Okay. Let's name the currents. So we can assume the current to this, for example, I1, I2, is here, and on double dash. So then we apply KCL at node VA. KCL says the summation of the currents that going into the node equal to the summation of the currents that going out of the node. So what is going into the node? A Mr. IS only, nothing else. What is going out of the node? I1 going out of the node, I2 going out of the node, and IA double dash is going out of the node. Okay, what is IS? It is 5, it's given, 5 angle 30. What is I1? I1 is equal to, I1 is basically the current flowing into the minus G4, okay? So it's equal to the voltage across the minus G4, which is that terminal, VA, minus that terminal, which is basically 0, divided by the amount of the impedance or the reactance, minus G4. Good, plus I2. I2 is flowing into the 6 ohm. It's equal to the voltage across the 6 ohm divided by the 6 ohm, right? So the voltage of the 6 ohm. So it's flowing like that. So it comes from the positive going to the negative. So it's equal to the positive terminal voltage minus the negative terminal voltage over 6. Over 6. What is the positive terminal voltage? It's VA. What is the negative terminal voltage? It's 0. Good. Plus IE double dash. IE double dash is flowing through the 3 and the G4 at the same time. They are in series. You can consider them as one reactance, one impedance. Okay? So 3 plus so it's equal to the voltage at that node minus the voltage at that node over the over the summation of the two resistances. So impedance basically. Okay. That node is VA. This one is VA. This one is basically 0. Good. So 5 angle 30 equal to VA over minus G4 plus VA over 6 plus VA over 3 plus G4. That's equal. Let's take VA as a common factor. 1 over minus G4, 1 over 6, 1 over 3 plus G4. 5 angle 30. So from that, VA is equal to 5 angle 30 divided by 1 over minus G4 plus 1 over 6 plus 1 over 3 plus G4. Okay, we're gonna use our online complex number calculator to do that calculation for us. We don't need to do the simplification by ourselves, but it's much better to use this online calculator using rectangular form of the complex number. So we have to convert that guy into a rectangular form, x plus gy. Okay, so we have another like website that does that for us. I'm gonna leave the links in the description. So this is the one, interactive mathematics calculator. You enter here the radius, which is 5, the angle 30, press calculate, it gives you the answer. So VA equal to here 4.33 plus 2.5 J divided by 1 over minus G4, 1 over 6, 1 over 3 plus G4. Okay, now we can use our online calculator to do this calculation for us. So we have a fraction, so we need 2 parentheses, always use parentheses. 4.33 plus 2.5 I, because I and J are just synonyms here. Okay, but here use I in that website. Then divided by 3 terms. So add it together. So 1 term, 2 terms, 3 terms. And they have a positive between them. Okay, 1 divided by parentheses minus 4i. Again, this website, you put the constant before you put the r. And don't make two like two I can't remember the name, like slash then negative slash then positive, you know, directly. So we put a like a separator, which is a parenthesis between the slash and the minus. Okay, then 1 over 6. 1 over a parenthesis 3 plus 4i. Let's review. For review is very important when you do complex numbers. 5j for I, 1 over, that's good. 1 over 6, that's good. Okay, let's calculate this guy. Okay, so we have VA equal to 16.24 plus 3.62 J. Remember, that's not what we want. We want I double dash. I A double dash is equal to, let's review here. IA double dash is flowing in that branch. So it's equal, as we said, VA minus 0 over the total resistance or total impedance, 3 plus G4, as we explained like a few minutes ago. So it's equal to VA divided by 3 plus G4. Okay. We have VA. Just copy and paste. Copy and paste. Put it in a parenthesis. Then divide by 3 plus G4. 3 plus 4i. Again, we put the constant before the I or J. So that's the result. So IA double dash is 2.5253 because it's 2.8, so we round to 3. Minus 2.16 J. Okay. Now the moment of truth. That's a superposition. Okay. We know that IA should equal to IA dash plus IA double dash. Okay. So number 3, the last step here, IA equal to IA dash plus IA double dash. Equal. Okay. What is IA dash? IA dash is 1.57. 1.57 and plus 0.55J plus 0.55J. And IA double dash is 2.53 minus 2.16J. Okay, let's do this in our online calculator as well. We don't do any simplification ourselves. Okay, and yes, because we are afraid to make any mistakes. We are so truthful about that, you know. We don't want to do any mistakes, so we use the online calculator. So plus, I'm sorry, plus That what is was the first IE dash is 1.57, 1.57, 55J, point plus 0.55I. Okay, let's calculate. Yes, that's the correct answer. So IE equal to, what was it? Sorry for that. Like, yeah. Okay. So it's 4.1 minus 1.6 J, or in angular form or polar form, I'm sorry, 4.4 angle minus 21. Again, it gives you the angle as a degrees, minutes, seconds. You go down a little bit, you're gonna find the the decimal form of it. Minus 21.49. Let's again review. I know that is the correct answer, but let's review 49. So we get here 4.4 minus 21.49. Let's review the Thevenin. Okay, we're using Thevenin. The final answer was 4.4, 2143, 2149. And of course, both are minus. Very close, right? That's basically what you should get. You should get very close answer to whatever the method you use. It's a method to find the truth, a method to find specific value. This specific value should be the same, whatever the method you use. Either using Thevenin, mesh analysis, nodal analysis, or superposition, you should get always approximately the same answer. Okay, guys, thank you very much for watching, and see you in another video. Bye-bye.